Okay, so now we're going to talk about graphing these functions. Usually when I'm asked to graph, I have an idea of the parent graphs, which were up here. I can look at transformations in some cases, but in this case we just have the very basic logarithmic graph, and I can make an XY table like we typically do. So if I have an X table, XY values, I'm going to strongly encourage that when you have logarithm, we're going to change them to exponential functions before we plug into here. So if I said 1/2, and this is actually y, this raised to this equals x. So this is really becomes 1/2 y equals x. And let me rewrite this. Log of 1/2 x is equal to, remember f of x means the same thing as y. So if I put that over here, then all I did was rewrite this function. I swapped sides and then put y so that you can see the familiarity. This raised to this equals this. And that's exactly what I have here. Now, because this equation is solved for x, instead of doing what I usually do and plug in values for x, this time I'm going to plug in values for y because it's easier to plug in here and solve. So I'm going to pick some easy ones. 0, 1, 2, -1, and 2. And it shouldn't be too hard for us to do, and especially with a calculator. So if I plug 0, 0 in for y right here, that would give me 1/2 to the 0 power, which is just 1. Okay, and if I went ahead and plotted that point, we know that 1 0 is on the graph because we made that comment up here and we said 1 0 will always be on the graph of a parent function. Alright, now let's change this to, let's test it when y equals 1. That means I'm going to have 1/2, and then this time in place of y I'm going to put 1. Well, 1/2 to the 1 power is just 1/2. So that's over 1/2 up 1. Whoops. 1 0 up 1. If I had 1/2 to the second power, you put that in your calculator and you would get 1/4, or the decimal 0.25. So 1/4, 2. So you can see you get smaller and smaller and smaller. If I was to put 1/2 and I raise it to the -1 power, then my answer is 2. So it's 2 -1, which is here. And one more time, I'm going to plug in a 2 for y, and that would give me 1/2. Actually, that's a -2, excuse me. -2 in, I would get +4. So you can see our graph is going to look like that. Okay, which was similar to the one that was on the right. And we knew that because our b was between 0 and 1. Now, look at number 5. We know our b is greater than 1, so I'm expecting it's going to have this shape of this parent graph up here, right here. So when b is greater than 1, but let's see this out. The first thing I'm going to rewrite it as log base 2 of x, and instead of putting f of x, I'm going to put equals y, and I'm going to move it to the other side just so it's familiar to me from the way I showed you above. So 2 to the y power is equal to x. So this is from logarithmic form to exponential form. This exponential form is always much easier to work with when we substitute values into our table. Okay. Typically we pick values for x, but this time I'm going to pick values for y because I can see if I substitute y in, it's real easy to find x. So let's do our, when y is 0, 2 to the 0 power is just 1. Let's do when y is 1. So that means 2 to the 1 power is just 2. So that's the ordered pair over 2 up 1. Let's jump to 3. I could do a 2. 2 squared would be 4. I'm just going to jump to a 3 and say when y is 3, I would have 2 to the third power. So 2 to the third power is 2 times 2 times 2 is 8. So that means I would go over 8 up 3, so something up here. And then let me make something small. Let's pick something easy and negative. Let's just do -1. It means if I was to plug in a -1, I would get 1/2. So, and that was the shape we were kind of expecting. Okay, because this was our parent graph when b is greater. So we see 2 different examples. We see how we can change it from logarithmic to exponential, and then use our xy table to get some specific points. Another thing we can do is we can use our transformations when we're graphing logarithms and logarithmic functions. So it says graph each function and give the domain and range. So first of all, this b is greater than, my b is 2, so that means b is greater than 1. I'm automatically, I know it's going to have this shape. So in my mind, I'm thinking that. And I also know that all of the logarithms go through the ordered pair 1, 0. Okay, so let me go start at 1, 0. I know my parent graph of this guy usually goes through this point and looks like this. But this specific graph, if this is in the grouping symbol, this means to shift to the left 2 units. Okay, think back to transformations. If it's in a grouping symbol, it tells you left or right, and we think opposite. If it's outside of a grouping symbol, hence over here, you think up or down, just as you would guess instinctively. Alright, so let's jump back over here. I know it goes through 1, 0, so it kind of make me an idea. And then using transformation, I go left 2 units. So if I was to take this to the left, 1, 2, and then kind of sketch my shape. Now that's not a perfect drawing, but this is a sketch, and usually the homeworks associated with this have multiple choice, but I could always make an XY table and plug in values to get exact values if they ask. Okay, the domain is the x values, the leftmost x values. Okay, so if that's at -2, because it's going to get very, very close to -2, but never cross and touch it. So the domain is going to be -2 to infinity. So the leftmost point will get close to -2, but never go past it. And then the rightmost point will just keep going on and on and on for infinity. The range is your y values. It's the bottommost point, which the bottommost is an arrow pointing down. The topmost is an arrow pointing up, so -infinity to +infinity. Alright, we move over to number 7, and this is going to be greater than 1, so our b is greater than 1. We will have this parent graph shape. I know the parent graph goes through the point 1, 0, and then this shift, if it's outside of the parentheses, tells us we go down 2 units. So using transformation, our rules for transformation, we just simply move this graph down 2 units. So we go down 2, and then we're going up through there. Just to give a rough sketch. Like I said, if I want an exact, I need to make an XY table and solve that out. So your domain is going to be from parenthesis 0 to infinity. The range is your bottom to the top, so it's -infinity to +infinity. Alright, and we finish with one more. So this is going to be, once again, we see that the b is a 4. B is greater than 1. It's going to have that basic shape. It goes through the point 1, 0. But I'm going to shift. If it's in a grouping symbol, we think opposite. So I'm going to shift right 1 unit, and it tells us left or right. Right 1 unit, but what does this plus 1 tell us on the outside? Up 1 unit. So let me remind you of transformations. If it's in a grouping symbol, you usually move left or right and you think opposite. And if it's outside of a grouping symbol, it simply tells you how many to move up or down. So I'm going to start at this point and move right 1, up 1. So right 1, up 1, approximately here. And that means it's going to get closer and closer to this line, so your domain is going to be from 1 to infinity. The range is your bottom to your top, so negative infinity to positive infinity. And like I said, we did sketches using transformations. If we were to do exacts, we'd have to change this to exponential form and then make an XY table and get some exact points.